All right. Hello, welcome to the stream. And sorry I'm a minute late. I hope you all weren't waiting. It is a very cold Sunday here today. We've got snow drifting up on the street on the side of our house. And most of the central United States is getting hammered. So please stay in, stay safe, don't drive, and hopefully we'll all continue to be healthy. Anyway, I hope you had a good New Year. Mine was pretty good. I got to go to a excuse me a second. Let me light myself up here. Okay, that's better. I got to go to a wildlife preserve. Had a very nice New Year's Day, and saw some bald eagles, which was pretty cool, and celebrated my birthday. So, all right. Today, I think, is going to be the last stream on HanoiDB. We've been working on it for a very long time. And I think it goes to show that this sort of system is very deep. Even for a simple, single-threaded, not memory matched database like we built. There are so many things to consider, and it's very challenging to do things right. So, I always had a great respect for the folks who worked on the storage engines inside React. But now it goes even deeper, my appreciation. So if you work on that sort of thing, kudos to you, and thank you for your contributions to technology. Anyway, I think we should get started. So let me pop over, and we'll get going. Okay, so this is where we were. I'm guessing this is session 23, so I'm guessing I didn't push from last time. Okay, and I think we're going to bump the text up a little bit today. So last time we were trying to optimize range scans, right? So we got into a case where the behavior for the inner nodes of the B tree have to be they have to be different than the leaf nodes. The leaf nodes, it's like you can treat it as a contiguous array of actual values, right? And I say contiguous, it's ordered. But for the inner levels, what we have are pointers to so like the inner levels have pointers to other blocks, and that's the poslen, so position length entry, in contrast to the key value entry or the deleted entry. Not now, thanks. Sorry, I just had something on my keyboard. Okay, and so we only know the beginning of the range of that block, and we don't know what the last key in it is. Now, maybe this is an enhancement we should make to the file type, to the file format. It would actually be a pretty simple change to make, and it would be very impactful. But we don't have that right now, so we're trying to make up for that by, if we're on an inner block, then we look if there's another entry, and if there if there is another entry, then we peek at what the subsequent entry is. So we know the range of keys that are within the block that that points to. And then we're doing some garbage down here that is just like, oh my gosh, want to tear my, hair out. And I think between streams, I had a realization, which is the problem I'm trying to solve here is not, should I look at this block? It's, what is the range of keys here? And consequently, does the range we're trying to scan over overlap that range? That's the essential problem. And I think last time I was just caught up in like all these, look at all this, logic here. It really comes down to, can we construct two ranges and compare them? We already have one range constructed. We need to construct the other range. And then we needed to have unified logic for, do these ranges overlap? So I want to, so we don't really have a util module. I think it'd be appropriate in scan. Or maybe we'll make a new file. Let's make a new file and call it range. And let's add it to the library here. Okay, so we're going to basically, we're going to create a trait, because this does, as far as I know, this does not exist in the standard library. Okay. There is no overlaps. It has bounds. It has this range bounds thing, right, which we're going to use here. But there's no like range overlaps. This only defines three methods. So we're gonna add so we're gonna add a trait overlap. How about range overlap? Okay, and it's going to be generic, and it's going to have to depend on this being, because we're going to make a generic implementation, right? We need to know that the type that implements range overlap also implements range bounds. Okay? And then we're going to do this is going to be tricky because we have two sides, right? So we're going to have a type RHS, which also implements range bounds. T. Okay, so overlap, and that's going to take self, and it's going to take RHS, which is RHS. It's going to return a bool. Now we could potentially, I don't know if there's any type constraints on T here, but I think we'll save that for the implementation. So really quickly, what we're trying to do is go do these two ranges overlap with one another on the same domain. Our case, this is vec u8, but it could be anything. Okay. And now I want to make an implementation. So we're going to have T is the inner type. R is the range. So it's the type that implements range overlap. Actually, let's give these better ones. So V is the inner type. T is the type we're implementing it for, and O is the other type, so the right-hand side. Okay, and we're going to implement range overlap of V for T, and we need to put some constraints on it. So where V has partial ORed, because we need to be able to compare them. T implements range bounds, T. Range bounds of V, excuse me. Right? And then there's one other. What's the other one? O implements range bounds of V. Okay, so both of these implement this range bounds trait. Yeah. Okay. So then we'll say type of RHS equals O, so the other. And overlaps. Okay, so here's where our logic should happen. So we need to figure out what the logic should be here. And the essence of whether two ranges overlaps comes down to is an end of one contained in the other, right? Now it gets trickier with these included and excluded, and maybe we can get around that. But so we basically just need to test. Okay, let me take a moment here. This is also bijective. So if A overlaps B, then B also overlaps A, right? So it doesn't matter which order we do this in. What matters are the endpoints and the and whether they're contained. Okay. So this is not straightforward for all types V, right? And what? Okay, there's the format. Okay, so here we'll just say to do for now. I need to fix that. Okay, and then we can do that here. Okay. Honestly, let's just make it do O. Those are equivalent. I don't know why it's complaining there. Okay. So we need to look at the bounds of self. And we'll look at the start bound. Now we could do something like, let's just do self.start bound. Okay. So if it's, I'll just name those start. So if it's unbounded, we're going to do nothing because we don't know whether this is going to have any impact. Because these will be returns, right? And this one is simple. This is RHS.contains start. Now the type isn't correct there. No, that is correct. Okay. So for excluded, we probably need to do something trickier. Right. So if this is an inclusive bound and the other range includes this, it contains this item, this value in its range, then that's obvious, and this is return, because we want to return early. And we'll just do return false here, and we don't need special return because it's just the end. Okay. So now we don't, this is a return early. So I think if it's an exclusive bound, then what we need to do is get let me think about this. The other thing we're going to do here is match self.endBound and do something similar, right? So here we're just going to return true because we and this is where I'm actually thinking it might be good to match these at the same time, because we can make a case for if both of them are unbounded, it doesn't matter what the other range is. Let's continue down this path, though. Okay, so I think in this case, yeah, it's these excluded bounds that get tricky. This is another case, though, if it's included, because we know exactly okay. So actually, let's think about this a little bit differently. Let's do this joint. And again, I may have trivialized this. Yeah. Okay, so we're gonna say for the patterns where the bound is included, Let's just enumerate them. Okay, let me comment these out, right? So here, the combinatorics are getting me like they did last time. I'm conceptualizing the problem. So it might make sense to draw something out here. So let's say you have the ranges are this, and we're trying to compare okay. So what are the easy cases? The easy cases are this one is range full, or this one is range full. Then it doesn't matter what the other one is. Okay, so let's all right, trying to be too helpful. So if it's unbounded, then the answer is just true. Okay. So in this case, it doesn't matter what right-hand side is. So let's enumerate the other possibilities. What are the other types in here? So this is, so we have range from. So that would be, and I'm going to put a little comment on here. This is range full. Range from. This is bound, included, start, and bound, unbounded. Okay, in this case, we know that start is part of the range. So then we just need to know, does it contain start? Okay. Okay, range from, we have range full. Let's do range inclusive, because that's also easy. And that's bound, included, start, bound, included, end. And this is, the range contains start, or range contains end, right? Because both of these are part of this range. Let me put the base case in here. Okay, so it quits complaining. What's wrong here? Expected pattern, need comma there. Okay. So now a range inclusive. Okay, and then we can do range 2 inclusive. That's easy. Right, because we know what an element of the range is. Here. So this is unbounded. Is it easy though? Let's find out. So included end. Here's the thing though, this is not actually true. So if it's range full, of course, it always overlaps everything, including range full. If there's an inclusive bound on the start and unbounded on the end, so from whatever this to infinity of that type, then one of the cases is the start is inside the range. But the other possibility is that the other possibility is that the other range has one of its elements contained. So I think I don't know that we can get like recursive well, that's garbage. That's not right. It is constrained here. Okay. The other possibility is that what we have to do is either it contains start or RHS overlaps. I'm a little bit worried here. Right? We're going to run out of... Like, there's a possibility that that just loops. And we'll need to think about that. Okay, so we will only evaluate this if it doesn't include the start. So that would mean that it's going to go through these checks on itself and say, does my start or my end get covered by the other range? So it's a little bit like reflexive, but we're going to need to make sure we don't get into, you know, a recursive loop here. Mutually recursive. Yeah, the problem is, what if we do this one and we go, okay, so the right hand side doesn't contain this. I need to convince myself that this is like, so let's say this is range from. These are both range from. This is range from A and this is range from B. So range from B does not contain start in this case. But if we come back and this one is this one is B, because they both have an upper bound that is unlimited, one of them is going to contain the other. We're gonna have to write a lot of tests for this. And like this is somewhat exacerbated by the fact that you have this enum here. And so you have what, like 6 possibilities. for each one. What we might want to do here, I think I'm going to comment that out and just say we're going to have to deal with that. But we have the same problem here. Because, you know, we could have something like, if this is range 2 inclusive, this is that, but this could be B ... right? In which case they don't overlap. We'd hit this case, and yeah. Honestly, we have 1, 2, 3, 4, 5, 6. Six and 6, we have 36 possibilities. That's a lot to enumerate. The question is, can we simplify? The other way we could go here is I want to do that, by the way. That doesn't help. Yeah. The other way we could go here is go through each of these and implement it specially. And I think that might be simpler than this generic. And then if we find commonalities, we can compress them. So why don't we go ahead and do that? Because the generics on there are making me dizzy. Okay, so we're going to impl t, impl vt, range overlap v. But we don't need that. And this is for let's do the easy one. Rangeful. Okay, do need some generics there. So right hand side is O, and overlaps is true. Like, this is the simplest thing. Cannot for type parameter O. don't think that this is going to solve it. We could say this is range bounds t. Range full does not implement range bounds. Yes, it does. It does. All right, let's look at these in more detail rather than just hover. Okay, so it's saying this is unconstrained. Cannot satisfy. Oh, is this the issue? Question sized. I wonder if it's this. Type annotations are and more impulse found in the following crates core. This is a little cryptic. Saying type annotations needed. Let's look up this error real quick because I think I'm getting lost. Rusty error 0283. Could not infer a type and ask for a type annotation. This error indicates that type inference did not result in one unique possible type. And extra information is required. Oh, I see. So because this is an associated type, and not right. Okay, so this is wrong actually. And what we need is not an associated type, but another generic. And this is O. The other thing that we could do here is, rather than specify it with a generic, we could put impl, I don't remember if impl in trait is a thing. So let's just fix that. And we'll say O. Because when you implement something for a type here, yeah, fine. We don't actually care about that. If you implement something for a type here, then yeah, never used. Fine. Then you can only have one implementation for that type. And so you can't have multiple competing implementations with an associated type inside it. The associated type is more for things like iterators. We want this to be generic over anything that is range bounds in size. This means you can't have a reified type inside it. So this kind of fixes some of the problems. But so now we'll get back on track now that we're no longer fighting that error. Okay. So I want to see, so range full. That's the easy one. And we're going to have to do something similar here. This is for range from T. Oh. Okay. And then we're going to have to enumerate it for all of these. So range from, let's do range inclusive next because that's the other easy one. Range inclusive, T. And this is just RHS contain there. We'll do the match in there. Let's leave it as to do. And we need okay, range from okay, we need range from, okay, and then we've got that. We need range 2. We need I should probably do these in alphabetical order. I think I was trying to order them by ease, but let's put range up here because that's the one you use most often. And we'll say range T, and this is to do. Okay. So range from comes next. We're going in alphabetical order. Then range full, and then range inclusive, and then range 2, and then range 2 inclusive. Okay. Now, remember when our first attempt here, we were trying to do it generic over all these types. But I think that the logic will be easier to understand if we're only concerned with what are the constraints of self, and then we'll adapt to what the constraints of the right-hand side are. And then if we find some I don't know, some unified thing, we can either extract it to a module level function, or we can compress some of these implementations. Yeah. Okay. So we know in this case, let's see. So we did range full. We know it always overlaps. Doesn't matter. Now for when we're working with these concrete ones, we can use the direct accessors on these structs rather than going through that range bound thing. So like, you know, start is directly available on range from. Okay. So on a generic range, we know that the start is inclusive and the end is exclusive. So let's do like we were doing before. Let's match on the start bound and the end bound of the right hand side. Okay. Let's fill match arms. Woohoo! Now I'm going to move this one up to the top because that's the easiest. In this case, we know it's you know, range full. So here we return true. Okay, so if both of these bounds are included, then we know if they're both inclusive, and this is exclusive, all right, but this is kind of the pattern we'll do. Let me do the easy one. Yeah, so let's go down here. Since these are inclusive, this is it contains self.start. Oh wait, wrong one. I'm on this one. Okay, we'll do it like that. That is not expected. Okay, what's wrong here? What did we do wrong here? Do we need to make sure that T implements partial order? Yeah, fine. Hi, Chris. Great stream yesterday, by the way. I wasn't able to watch that much of it, but I enjoyed it. Yeah, like it's funny because we were writing all this complicated logic last time to optimize range scans, and then it came down to the fundamental problem we're trying to solve is do two ranges overlap? And so now I'm trying to solve that. But the compiler's fighting me. I'm trying to make a trait that we're implementing over standard library types that says, does a range overlap another range? And, it feels like there's probably, maybe this is where I'll resort to Google. Range overlap algorithm. And maybe I'm doing it too hard. So this is also like, these are all inclusive ranges. We could look at this a bit. I mean, this is the simple solution, right? If they're inclusive. The problem is if they're exclusive, there's like, well, is this range discrete or continuous? And it's not clear in this case. Yeah. Visual approaches do help. But this, with Rust, we have more kinds of ranges than just this inclusive on both ends range that they're talking about here. This feels like a freaking LeetCode code exercise. Which, I'm trying to be as efficient with it as possible, or like simplify to the essence of the problem, not necessarily efficient, but simplify to the essence of the problem, and the compiler's fighting me. Okay. So, oh, that's only pub to crate. Boo. Yeah, it's totally LOL elite code. I would never make it into a FANG company. I'm sorry. I'm okay with that. I'm old enough to be okay with that now. Okay, so this should give us the right thing. The problem is... Right, okay, so we don't have the bounds correct up here. Oh, and Z is doing that thing where this closed tab thing won't go away. So I'm going to have to restart. So obnoxious. I don't know when it does that. I haven't figured it out yet, but... okay, so what this is telling us is we need partial OR on T. And then we're going to have to duplicate that constraint everywhere down here. So that when we get in here, it won't complain about those not meeting the constraints. Okay, so now that's happy. That's what that problem was. And I'm going to bump up the text size a bit again. Okay. So we've got range inclusive. Again, easy. It's, does the start of this one, is it contained in the other range, or is the end contained in the other range? That covers the case of, are we overlapping on the left or are we overlapping on the right? Okay. So now... Let's do some of the ones that are unbounded on either end. And I think that they're going to be a bit simpler to handle. Okay, so for range from, it says it's pub, but I think it's pub crate. It sucks. Okay, so here, either on a range from, either the start is within the other range, so it's contained, or either bound of the other range is greater than start, greater than or equal to start. Okay, so if it's overlapping on the left, then start will be within the range. If it's overlapping on the right, then both bounds, because this is unbounded on the upper range, right? Both bounds of the other range are greater than start, greater than or equal to start. So really it just comes down to, are either bound greater than or equal to start? We don't have to test whether start is within the other ranges. Okay. I'm going to do this as a match on either one. So so if it's included, then this has to be other is greater than or equal to self.start. Okay. And here, well, this is an included bound, an inclusive bound on the left that we're testing against. So it actually doesn't matter. I don't know who uses excluded bounds on the left. That's just weird. You know, one thing we could do is just not implement it for some types, but the problem then is we're going to run into issues where the wait, hold on. Let me think about this again. I'm trying to be like cover all the bases, but the problem we're trying to solve is we either have this range from, right? So this would be the last entry in an inner block. It's like, my key starts at this, but who knows what goes beyond. Or we have range. So we really only need to implement this one, which we'll get to, and I'm gonna just delete all that and save to do. Or this one. These are the only two that we care about. We're never going to have range full, even though that's easy to implement. We're not going to have range inclusive because we know the next key is the start of the next block. So we don't have to care about that. And we definitely don't have to care about these unbounded on the bottom. Because the if the range we're scanning, like, it's always going to start with something. Or rather, a block is always going to start with a key. It doesn't have an unbounded on the left. If there's unbound on the left, we know that we don't have that key, right? So we can delete a bunch of these. So we don't need to implement range 2. And we don't need to implement range inclusive. Or range full. Now, for completeness sake, I might want to do that later, but we really only care about regular ranges or looks like I need to do partial equal. Cool. Partial OR plus partial equal. Well, no, that implies that you have partial equal, right? If you have partial ORed. Self as partial equal, right? So I just need to make sure that it's on here. Right. That should solve that. Okay, yeah, delete all the code. Yes. I'm going to delete as much code as I can. Okay, so we only care about these two kinds of ranges. Okay. So I'm going to do this a little bit janky. So if this is necessary, this test on the first clause here is necessary but not sufficient. And I'm wondering if there's something generic over this bound type that we could do. Okay, so we know that this is unbounded on the right. And I had written some stuff here that I deleted and I shouldn't have. But this is either self.start is contained in the other range, or either bound of the other range is greater well, it really comes down to is contained in self. The problem is this exclusion. And that's I think if we can puzzle that out, that's going to be the essence of the solution to both of these. Unbounded is a little bit tricky, but not as bad. I think that maybe what we'll do is we'll just do a dumb, additional match here. I'm gonna put to do. Again, this is necessary but not sufficient. I think what this should be is self.contains other. So if it's inclusive, then we know that this range has to contain it. And then let's fill that out. Oops. Fill match arms. Okay. This is... So if it's unbounded on the left, then we know that self.contains other. This is the solution here. Okay. So if they're both unbounded, then the answer is true. Right? Because that's our range full. Let's see here. So I think that here we can say that what we care about is so this is exclusive on the left, which means that the possibilities are either both of them are included, both bounds are included in this range, or the end bound is within the range. So we really need to we possibly need to have another clause here, which is does this bound equal self.start? Yeah, and again, if we are doing this, for the other, for this, which is going to be more likely the case, this is where we're at the end of the subtree, the inner node of the tree. I honestly don't know who would give us an exclusive range on the front. Maybe they want, okay, let me take a step back. Maybe they want everything after a certain date, and the keys are dates in a lexically sorted form. Like they used ISO 8601 time format, and they're like, give me everything after midnight on January 1st. Yeah, I know. Your famous last words. Absolutely, Chris. Dooming myself. Okay. So maybe let me think about some cases here. If other is greater than self.start, then it doesn't matter what the end bound is. This is true. So I'm going to make that into a guard. And maybe we can compress this later or make it into one clause or something. So I now need excluded other equals self.start. If they're equivalent, then that is also true, because the lower bound of this other range, we're inclusive, right? So I think that I'll combine these. And it doesn't matter what the upper bound is. So if other is less than self.start, then we have to care about the end bound. Okay, so are you all following this? This means that if the lower bound of this other range is within our range, because our range is unbounded on the upper end, then we don't care about the upper bound of this other one. This is included. So now we need to deal with, and let me rename this start. And that's maybe not the best name, but here, start. Okay. So now we have to look at the end bound. And again, if it's included, and it's possible that these two cases will get compressed. But let's say this is end. again, we only care if so here we're going to have to do comparisons against start again. I think I'm getting a sense of how this is going to go for right. So this, if the end is greater than self.start, then it's true, right? Because we know that it's exclusive on this, but it's strictly greater than our inclusive bound. And I think this will compress. So if it's equal, then it doesn't overlap, right? Because you're excluding start from that other range, so it doesn't overlap. So I think this actually just becomes, if it's exclusive, then this bound has to be strictly greater than start. So that's the essence of it overlapping. And then, of course, if it's unbounded, it's true. I think we're going to run into something similar over here. And let's rename that end, and rename that end ex. And I think, yeah, this is the same. We're getting somewhere. Okay. Now we can remove this constraint, because if it's not greater than or equal to, then it is less than. I think that was instructive, but not necessary. Okay. So now these contain the same code. So we can say, put a pattern here, bound, unbounded, and then remove this clause. That's pretty nice. And okay. So let's have a look at this and make sure it makes sense. Okay, if the thing we're comparing for overlap, if its start bound is inclusive, then is it contained in this range? That's all, you know, this does basically a bunch of the logic we're doing on here, but it's already implemented for us. Okay, if it's an exclusive lower bound, and that is greater than or equal to our start, since our start is inclusive, then we know that this is contained. And we don't have to look at the end bound at all. But if it's less than, or the lower bound is unbounded, then we have to look at the upper bound. And my cat just came out of my lap, so if you see a tail flipping in the screen, say hi to the people on the stream, Bianca. Oh, she hates this. She wants to be on my lap but not manipulated. Okay. So if uh-oh. Give me just a moment, folks. The reason why Bianca hangs out in my office is she has asthma. And so having her nearby me on my workday is good for cases like this where she gets an asthma attack. Probably hear her coughing. Okay. All right, folks, we're nearly there. I'm guessing that we'll have a similar thing for this implementation. Okay. So let's get started. Let's think about what this is. Here, our upper bound of our range is exclusive. So that's going to mean some interesting things. But it's going to be a bit more complicated than this one, because this one had an upper bound which was exclusive, which means we don't have to handle a lot of other cases. How do you handle an asthma attack for a cat? Let me show you real quick. So she's got this, what they call arrow cat. Basically, it has this face mask that you put over their nose and mouth, and they end up breathing through there. And then you attach the inhaler to this end, and she has two inhalers. One that's her daily, maintenance medicine, which is fluticasone, also known as Flovent. And then she's got an emergency one for attacks called albuterol. And you basically put the nozzle of this into this end. You press it down and you put this against their face and let them breathe. It's got a little indicator. You can't see it that well probably, but if they're breathing, this little flap will move as they breathe. And so you can count the number of breaths that they take. Okay. Thanks for your questions, Chris. Okay, so let's do this. So I think we're going to start with a similar pattern to what we did below. Okay, so if it's included, I think this is the same, right? So if it's start, then the other option is, so that is, again, we talked about necessary, sufficient. This is one option. What we might want to do is explode this to what are all the bounds of the right-hand side, and then yeah, let's do that. So we'll start over real quick. And we're going to fill all those. Okay. So this one is easy. Let's start and end. So this is self. Okay. So for this inclusive on the target range, this means self contains either bound. It doesn't matter which one. Okay. Oops. So if the start is inclusive, so either self contains start excuse me. So with exclusive bounds, we had to look at what are the edge cases, right? Maybe what we'll do is we'll skip this. So if it's unbounded, we know this is true. That's easy to answer. If it is a range 2 inclusive, then this is also easy to answer. It just that's not actually the case. That is, again, a necessary but not sufficient. We're going to power through this, I promise. um, okay, so this is an exclusive start. I think I can answer this one. So what are the cases it overlaps? Really, this is any this is so either this contains the start, because we're inclusive, right? Or okay, why am I saying that? Because if this is strictly less than the end, because our end is exclusive as well. So like if these are both excluded, then this value, whatever it is not in either range. So if this is strictly less than the end, and this is unbounded on this end, then you know that it's within the range. And then we're just checking, does our range start within this range? We could do something like self.start greater than start ex, but I think this is more concise and consistent. And generally speaking, I think with the inclusive bounds, we want to use contains. Okay, so I think we could do the opposite one as well. Which is unbounded on the left and exclusive on the end. And this is that. What are the options? The options are really it's that well, it's either going to fully overlap, right, or partially overlap, or not overlap at all, because it's unbounded on this end. So, and I'm doing it opposite to the way you all would think about it with my hands here. So either only the start is within the range, or the start and the end are within the range. So we should consider first that does the right-hand side contain start? The other option is that because we're exclusive, our end, well, here's the thing. We don't actually have to consider the end, our end bound, I think, because it's, you know, unbounded on the left. We only care about does the start. Is our start included in that range? Anywhere within that range. If the start is included within the range, or rather, if the end is included within the range, then the start also is. But it's possible that our end is outside this range. So we can just go with that. and this one, we do have to consider the end, I think. Do we? Do we? If the end is inclusive, so this is our range 2 inclusive. I think, again, we only care about whether it includes the start. So maybe what we could do is think about compressing these. If it's unbounded on the left, then we really only care about, of course, if it's unbounded on both of these. Right? Now we do some extra work if this is unbounded, but it's not much if both ends are unbounded. Okay, that's interesting. I wonder if we have something similar with unbounded on the right. I think we do. That would be a great simplification. Now it's going to complain that it's covering a bunch of things, but this is... No. I'm prematurely jumping to conclusions. The problem is our upper bound is exclusive. So... but I think that we can start to think about these other ones. So, okay, so this is basically a range, like we are. If the bound is included on the left and excluded on the right. So this is simple. The inclusive bound is simple. It's, do we contain that bound? And then it doesn't matter what the right-hand side is. If we don't contain that bound, then we care about whether the end bound is included. So if it's... If this is exclusive, then I think we have something similar to this, right? If it's equal to start, then it doesn't overlap. But if it's greater than or equal to, or then it's greater than start, our start, okay, so this first option covers the overlap on the right. We're talking about overlap on the left. So the end here is exclusive and the start of ours is inclusive. So if they're equal, then there is no overlap because our start is excluded from that range. If it's greater than our start, then that's what we want. So and let's see, end ex greater than self.start, like so. Field, not a method, fine. So we'll do star ndx. Okay. Okay. So this one is easy. It's either the right-hand side contains our start, right? Because it's unbounded on the right. This is similar to this one. Okay. Or right, so that would be overlapping on the left, except it's like this. So right-hand side contains our start. The other option is it's like this, in which case we care about, and it's inclusive, right? So we care about do we contain. Okay. And this is the weirdest one. Like who does this? Who does this? Evil, evil, evil. Yeah, these. Okay, so if it's exclusive on both, I think that's a narrower case, so we could do those first. Yeah, like, I mean, I have to cover all the options here. Okay, so in this case, we have to be sure that. So let's think about the left overlap and the right overlap again. So we'll start with the right overlap. This is exclusive on both ends. So start. It has to be strictly less than self end, right? So this would mean that if it's equal, then we don't include, both of those are excluded. Okay. Or okay, so in this case, these are strictly inside our bounds, right? We include on the left, but it doesn't matter because this overrides that. So if ndx equals start, then it does not overlap. Okay, easy enough. And then we have here. Let me fix this. That's not a method. This is self.start. I don't know why it kept suggesting me methods, but whatever. Borrow there. Borrow here. Okay. So we are at our last clause, and then maybe we can reorganize these if they start to look like they have too many similarities. We might be able to do something like compress them based on one bound or the other. We'll see. Okay, So if it's exclusive on the left and inclusive on the right, we know that we can say if self contains the end bound, then it overlaps. The other option is that, and I'm starting to see the pattern here. I hope you are too. If the start bound is strictly less than the end bound, because they're both exclusive. I don't. Let's look at for some similarities here, and then maybe we can compress this logic. I think that I really felt like we treated this very methodically. But we might want to see where there's some commonalities. So the inclusive bounds, we could look at these cases. We could also look at the cases for the end bound and see what we can compress there. So for the inclusive bounds, they all have this self-contained start, right? And then the other thing is something else. Okay, so it's either right. Let's see if there's, and let me reorder these clauses a little bit for the sake of finding similarities. Okay, so for the exclusive bound, we are always checking this. And I'm starting to see a pattern among these as well. Right? There's parallels there. How do we compress this? Well, we can start by, let's just do matching on the start bound. And then for, let's put this in here. Or, and then there's a to do something, because that's the thing that's in common here. Oops. Okay. And for the excluded, this is this thing, right? Because that's the only thing that includes and then for unbounded, we already have this. We already have that. And then this also has this other option here. The only issue I see here is that the only issue I see here is that this deduplication is not straightforward. I can put this No, it actually is straightforward. We can do return here, and then for each of these, we do or match RHS.endbound, and then fill that out. The funny thing is, like earlier, I suspected this was going to be the pattern that we have, but I just couldn't put my finger on it. Yeah, okay, so now for this, we have end, and we have end exclusive, and then for unbounded, yeah. Okay, so for included, we have self-contains. The main thing here is that we just skip evaluating the unbound if this one returns true, right? Okay. For the end is exclusive. Then we have this, right? Want to keep this code around. And then if it's unbounded, we have that's interesting that if either of them are unbounded, it only matters whether okay, but this actually does okay. Why does that need a semicolon? Those are two expressions. I mean, I could do let start included is this. Let end included is this. Not what I wanted to do. Here, let me see if I can put this like that. And remove this, and remove that, and remove the let binding. This is what I was originally trying to do. Why did it complain? Is it complaining that this is a return? Let's get a more detailed expected type bool found closure? What? I mean, I could say if RHS.startBound is bound unbounded, return RHS.contains self.start. I don't see where the closure is. What the heck is going on here? And then here I can just unreachable. No. Yeah, it really doesn't like this. Why does it not like this? Oh, I had to put parens around it? Is that all? Oh, but then they put parens around that. Are you kidding me? What the heck? Oh my goodness. Okay. Wow, I've used up almost 2 hours fighting this. Don't care about that. Remove that. Okay. So here, okay. Now, my goodness, that is so bizarre. It is some kind of like grouping syntactical thing. Like it didn't like that I didn't have parens around it. Even though these are expressions that both return Boolean. Of course, this one has an early return, but yikes. Now, back to our regularly scheduled program. Okay, we were over here in the tree entry iterator, right? And then we were doing all this garbage, right? And I think that this comes down to what we're gonna do is we're going to be, so this range is the range we're trying to scan, right? This is going to be the right hand side that we were talking about over here. So what we want to do is we're gonna get rid of this, because this is not, we have deep logic for this stuff. So what we're gonna do is go, we're going to let block range, and we're gonna match on next key. And let's just do that. So if it has some end key, then what we want is we're going to take, this is entry.key 2vec, and we're going to do to end key 2vec. Otherwise, we're going to make basically this, but it's going to be unbounded because we're at the end. Okay, and we can get rid of this, and then we'll say block range contains range. Okay, now what's wrong? Okay, well, we're gonna have to do, we're gonna have to inline this then. So we'll say dot not contains. Why did I say contains? Regardless, it's overlaps. Now we need to import this this trait that we did. So we're gonna use create range overlap. Okay, and then where were we? Okay. Put more parens around it to make it happy. Overlaps range. And then we'll do something similar here. Okay, now what's wrong? Oh. Okay. Um... Now I actually wonder whether there's any other place that we're going to need this logic. But I think it's just here because we're in tree entry iterator. So we're either looking at an inner block or we're at the leaf block, and this isn't, we've passed this range down. So all these iterators have the range in them. So they're never going to emit anything that is not within the range as long as this logic is correct, right? So the real question is here, this logic that we just spent so much time building now becomes quite a bit more more straightforward. This is a match, but I'm going to replace it with if let. I like that better. We have an upper bound range of this block, and then this is the last block in this subtree. Okay. Now I think the question is, do our tests pass? Because last time we left it and our tests were failing. I should have run them earlier. I just got so caught up in making that logic correct. Ooh, interesting. Is inner is never read now. Let's see if we broke stuff. That's probably the insert a bunch of keys thing. Okay, so our range scan worked. It's passing again. Now I think the last step here is over here in scan. I think that we were doing a bunch of stuff with we don't need to do this anymore. Right, because now our tree iterators will stop emitting entries when they exhaust the range. So we don't have to care about checking that here anymore. And I think we deleted this last time at some other level. So we fixed it for levels. That's extra work we don't need to do. And let's make sure that we don't have it on the overall scanner. Yeah, we're not checking the bounds of the range anywhere here. We don't care. Interestingly, what this means is we don't necessarily have to keep a range here. We could put a marker on it because the range only matters, and heck, we don't even have to do it in the level iterator or the level scanner. We could put it, I mean, we're putting it down in the trees, right? See, it's saying this is never read. So I think what we'll do here is we will do range, and let's do phantom data. And then range is phantom data. Data. And we can do the same up here because let's see. Is it never read? No, there's something else. There's some place where this is read. Let's find all references. Oh, we need it for the nursery because we're not putting. Yeah, that's fine. Because we don't construct a special iterator for the nursery that contains the range. We probably could. But that seems like an optimization that's mostly stylistic, right? Yes, this would make the nursery iterator consistent with the others. But that would mean just that this logic goes down into that iterator. Okay. Can you give me the... Oh, I guess there's nothing there. I wanted to split up these. Anyway, so we removed that extra check. Let's make sure that our tests still work. And then we'll get rid of that onUse method. Okay. It is still succeeding. All right. Where's block? Now it's complaining we don't use this isInner. That's correct. We are using the isLeaf. But really, isInner is not isLeaf. All right, so this is let me look at the log. Yeah, we didn't push anything last time, so that's a shame. But here we are. So session 23, complete optimization of range scans, and complete is the wrong word. What I mean is finish. It's not total, but it is done. Okay. And that's a good place to leave this, I think. This will be the last HanoiDB session. So I wanted to talk about what we can do next time. And it really kind of comes down to what are you all interested in seeing. I have presented a poll a while back. I have lost that poll. I think I posted it on Twitter before I quit Twitter. So that's kind of a problem. But here's some things I'm thinking. We could do a web dev project. I am very interested in Gleam right now. Gleam, by the way, is a strongly typed language for the Erlang virtual machine. So you could think of it like Erlang or Elixir, but It's got a stronger type system. Its type system is somewhat similar to OCaml. No modules or anything like that. Module instances, it doesn't do that stuff. But it also feels a little bit like Rust. Its syntax has some similarities to Rust, and really, and also there's a neat web framework for it called Luster, which is kind of similar to the Elm architecture. So that might be kind of fun. Of course, Phoenix Live View has matured a lot since the last time I used it. I would love to look at that. Other options, we can do something like Chris is doing, do some game dev with Bevy again. I haven't touched that in nearly a year now. I have an idea for a game. It's very ambitious, unfortunately, so I may have to pare it back before we do that. I don't want to continue with databases for a while. I want to give it a rest. Yeah, Luster RE and look for Gleam. The other thing you can do is go to gleam.run. Yeah, I also maintain that time card. Oh, that's cool. Let me tell you what, since you're on, Chris, and thank you again for coming. Let me tell you what my idea for my game was going to be. For years, I have played an auto battler game called Teamfight Tactics, and I kind of was thinking of something like that, but more close to like a tower defense, where you have lots of units. So something like you have a battle, and you have squadrons of units with various capabilities, and your strategy is like, how many units do I allocate to each one? And then we let the simulation play out, and you don't actually direct. We might have some things like, maybe you could say target this space, or or give the squadrons like strategies. But at very first, it would just be like, set up your groups of units, lots of them, and then let them do battle. I think that would be really cool. The problem is, I would love to do that in 3D with somewhat of a limited perspective. So like a kind of forced isometric, but with 3D, or like just overhead at an angle type thing. But I don't really know any Blender. So that may consume a lot of the time. And there are some other options out there. I do have some things that I could probably do next week that are just maintenance things, revisiting some old projects. So if you have made it this far in the live stream or the VOD, drop something in the comments. Let me know what you think I should do. Yes, I could start with Kenny assets. That might actually be pretty cool. So I'll look into that in the meantime. And thank you for coming, and we'll see you next week. Hope you all have a good one.